It began with a flicker in the data, a subtle shift in the background of the night sky, one pixel brightening just enough to trip an algorithm trained to spot movement against the stars. No one at the observatory knew, in that moment, what they were looking at, but the coordinates didn't match anything in the catalog. Not a known asteroid, not a comet, and when the calculations came in, the truth sent a chill through the room. It wasn't set from here. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. In the past decade, 3 objects have carried that same signature. Oumuamua in 2017, 2I/Borisov in 2019, and 3I/Atlas after that. Each of them born somewhere beyond our sun's reach, traveling along paths that betrayed their foreign origin. Each of them reminding us that the solar system is not an isolated bubble, but a crossroads. And now there is a 4th. It is moving fast. Too fast for a typical comet or asteroid, bound to the sun's gravity. The numbers tell the story. It came from interstellar space. It will pass through, and it will leave again. This is not a body trapped in orbit. It is a visitor. When Oumuamua first appeared, it was easy for some to dismiss it as a rock with an odd shape, a coincidence of physics and perspective. But its acceleration, its strange, subtle push away from the sun, defied the expected path. Borisov, in contrast, was more familiar. A comet with a tail, its icy core releasing gas in a way we understood. And 3I/Atlas blurred the lines again. The truth is, each one has raised more questions than answers. This new object follows the pattern and breaks it at the same time. The Vera Rubin Observatory, still not even in full operation, caught it early. Its massive 8.4-meter mirror and 3.2 gigapixel camera, designed to scan the entire visible sky every few nights, spotted the object long before it reached its closest approach. That means we have something we've never had before. Time. Time to study it, to track it, to coordinate telescopes across the world and in orbit, to analyze every wavelength it reflects and every particle it sheds. Already, the early data is strange. Its light curve suggests rotation, but the pattern isn't clean. The reflected light changes not just in brightness, but in color, as if its surface is a patchwork of materials. Some regions are highly reflective, almost metallic, others dull and dark. That's not unusual for certain asteroids, but the distribution here seems too sharp, too defined. And then there's its speed. Even for an interstellar visitor, it is fast, closing on the inner system with a velocity that leaves almost no room for gravitational capture. There's a sense of urgency now. Teams are racing to prepare instruments. Radar arrays are calculating windows for possible pings. The possibility of sending a probe, once a distant dream, is on the table. The thinking has changed. The past few interstellar encounters were gone before we could react. Now, with Vera Rubin's early detection, the window is wide enough for bold ideas. Interception, close-range imaging, maybe even sampling. If this seems ambitious, it's because the stakes have shifted. Every one of these interstellar objects is a messenger from another star system, carrying in its chemistry and structure the history of worlds we may never see. Their compositions can tell us about the materials forming planets across the galaxy. Their trajectories can hint at the gravitational landscapes they've crossed. And if any of them were shaped, guided, or even built, then they would be more than just messengers, they would be contact. That is the thought, hanging in the background of every discussion, not stated openly in official channels, but whispered in hallways and late-night calls between researchers. Is it that Oumuamua's odd acceleration still haunts those who studied it closely? Its thin, elongated shape, its lack of a visible tail, the possibility that it was a fragment of something larger, or something designed. Could this new object be the same? Could it be more? Philosophers and scientists alike are already turning over the deeper questions. If we are now detecting these visitors more often, is it because we've entered a busier region of the galaxy, or have they always been coming, and only now do we have the eyes to see them? The Vera Rubin Observatory has already found thousands of asteroids in its test runs, objects that went unnoticed for decades. With its full capability, We may go from spotting one interstellar visitor every few years to several in a single year. And what then? Will we find that they are all just rocks, each one unique but natural? Or will the flood of data bring something undeniable, a signal, a structure, a pattern too precise to ignore? This latest discovery has already sparked careful planning. The object's path will carry it well inside the orbit of Mars before it arcs back toward the void. Its speed will make rendezvous difficult, but not impossible if a mission is launched quickly. Engineers are sketching trajectories using existing spacecraft buses, missions that could piggyback on planned launches or adapt current assets. The dream is simple: to fly alongside it, to photograph it in detail, to send back the kind of close-up images that end speculation. Even without interception, the array of telescopes trained on it will pull every photon they can. Spectroscopy will reveal its composition, whether its surface holds organic molecules, volatile ices, or metals rare in our system. Its spin and shape will be mapped, and its behavior under solar heating will be tracked for any sign of non-gravitational acceleration. Every anomaly will be scrutinized. But beyond the science, there's something more primal. These are the first true visitors we've ever known about. Objects that were not born in the sun's cradle. Each one has traveled for untold millions of years, drifting through the darkness between stars. Each one has seen things we cannot imagine, passed near other suns, through other planetary systems, perhaps even near other civilizations. They are, in a sense, the galaxy's drifters, and when they pass through our small neighborhood, it feels almost rude not to greet them. Yet greeting them brings risk. If one day, one of these is more than stone and ice, if it is a craft or a probe, then any action we take will be our first act of interstellar diplomacy. We will not get a second chance to make that impression. For that reason, some voices argue for pure observation and nothing more. Let them pass. Learn from afar. Do not touch what you do not understand. Others disagree. To them, the opportunity is too great to waste. Waiting for an interstellar visitor to fall into our lap is impractical. These are the closest things we have to free samples from the rest of the galaxy. Every one we study in detail brings us closer to understanding how planets form, how materials travel, and maybe someday, how life spreads between stars. For now, the new object races inward, indifferent to our debates. Its path through the solar system is already charted with remarkable precision, its arrival and departure written in equations. The data will pour in over the coming months, and with it, speculation will climb. Every oddity will be examined, every unexplained quirk magnified under the lens of hope and caution. If the pace of discoveries continues, the way we think about our place in the cosmos may shift dramatically. The solar system will no longer be a quiet, closed loop of planets circling the sun. It will be a crossroad, a place where the galaxy occasionally sends its wanderers, and perhaps its watchers. And when the watchers come, will we recognize them? Will we be ready? This is what the Vera Rubin Observatory represents. Not just a machine for cataloging rocks, but a change in our relationship with the universe. It means we will no longer be blind to the silent travelers passing through. We will see them sooner, follow them farther, understand them better, and in that understanding may come a realization both thrilling and humbling. We have never truly been alone in our corner of space. The galaxy is in motion around us, and from time to time it brushes close enough to remind us. One day, perhaps soon, one of these reminders will not just pass through, it will stop. And when it does, everything will change. Until then, each new interstellar object is both a mystery and a rehearsal, a chance to ask the questions we might need to answer when the encounter is no longer just a visitor in the dark, but a presence that looks back. And somewhere, even now, the newest of these visitors is racing toward us, carrying in its silent spin the story of another part of the galaxy, a story we may soon hear for the first time. The story of this newest interstellar visitor is not just about the object itself, it's about what its appearance means for us, for our readiness, and for the way we now stand at the threshold of a new era in space observation. The detection was almost routine at first. The Vera Rubin Observatory has been operating in partial capacity, running early sweeps of the sky that already dwarf anything previous surveys could manage. Each scan covers such a vast portion of the heavens that even experienced astronomers are stunned by how quickly new objects are spotted, categorized, and tracked. But when the coordinates for this one came back, there was an instant break from routine. The parallax and velocity didn't lie. It wasn't bound to our sun. This was a pure interstellar trajectory, a long arc cutting through the plane of our solar system at an angle that could only mean one thing. It was born elsewhere. And unlike Oumuamua, whose discovery came too late for much direct observation, or Borisov, which was already shedding material like a normal comet, this object had been found with months of lead time before its closest approach. That made it more than a curiosity. It made it an opportunity. Early analysis of the light it reflected suggested a surface unlike anything typical in our own asteroid populations. It wasn't just a matter of being darker or brighter. It was the way the spectral lines shifted unexpectedly, hinting at a complex mix of materials. Some readings suggested volatile compounds locked beneath a crust. Others pointed toward high metal content. The variations were so sharp that some researchers began to wonder if its surface was layered, almost as if it had been through multiple environments in its journey. That possibility alone changes the stakes. If this object has crossed multiple star systems, and perhaps passed near multiple stars, it could be a capsule of galactic history. Trapped in its minerals and ices could be isotopic signatures, telling us where it formed, how it traveled, and what it has encountered. In a single interstellar rock, we could read the fingerprints of worlds we have never seen. The object's speed complicates everything. It's fast. Faster than Borisov. Faster than most inbound interstellar candidates. Modeled in simulations, that speed confirms its deep space origin, but also makes any intercept mission an engineering nightmare. Still, in the wake of recent technological advances, there are voices saying it can be done. A high-energy trajectory, leveraging powerful boosters, or even staged intercept craft, could catch it during its slower inbound leg, or on the outbound path after perihelion. The mission would need to launch within a narrow window, but it's no longer a fantasy. And that is the part where philosophy and engineering meet. Is it worth the cost and the risk to chase it? Some argue that the answer is obvious. Yes, if you believe that such visitors are rare and precious, you don't wait. Others caution against impulsive action, pointing out that we may soon be detecting dozens more, thanks to instruments like Vera Rubin. Why rush into a hastily assembled mission when patience might allow for better planning and a better target? But the counterpoint is one rooted in exploration history. The first time you have a chance to do something unprecedented, you take it. The human drive to see, to touch, to bring back knowledge from the edge. It doesn't wait well. The cultural conversation around these interstellar objects is shifting too. The idea that we might now be in a more densely populated part of the galaxy is not science fiction anymore. It's an open question. Interstellar objects could have always been passing by us, unseen, slipping through the gaps in our observational coverage. Now, with Vera Rubin and other next-generation observatories, those gaps are closing. We may discover that our solar system is more like a busy port than a secluded island. If that turns out to be true, the implications ripple far beyond astronomy. Every incoming object becomes a data point in mapping the galactic environment. The number, size, and composition of these visitors could tell us about the density of debris in interstellar space, the frequency of planetary collisions in other systems, even the likelihood that life's building blocks are being spread naturally across the galaxy. But there's also the unsettling possibility that not all visitors are entirely natural. The fight of Oumuamua. Debate still lingers in the minds of many. Its acceleration, its peculiar shape, its lack of comet-like outgassing. Theories ranged from shard of a shattered planet to an alien light sail. The scientific consensus leaned toward natural explanations, but consensus is not certainty. And so every time a new object is detected, that question reawakens: could this be one of theirs? The phrase first contact tends to evoke visions of ships in orbit or signals from distant stars. But it's entirely possible that our first true encounter with extraterrestrial intelligence could come in the form of a silent, inert object, a probe designed to drift through space, gathering information, waiting for a civilization advanced enough to notice it. The key would be in its structure, in materials or patterns that could not be explained by natural processes. Detecting something like that would force humanity into a moment of decision far sooner than most people are prepared for. The Vera Rubin Observatory's role in this unfolding story cannot be overstated. Built to scan the sky with unprecedented speed and depth, it changes the basic rhythm of discovery. Instead of hearing about interstellar objects only after they've already left, we will now know about them as they approach, perhaps even when they are still far from the sun. That kind of early warning turns passive observation into potential action, whether that means deploying specialized observation campaigns, coordinating global telescope networks, or mounting an intercept mission. Even in its test phases, the observatory has proven its worth, cataloging thousands of new asteroids and mapping faint transient events in the sky. Once fully operational, it will likely increase our detection rate of interstellar visitors by orders of magnitude. With that comes an inevitable flood of data that will not only fill scientific journals, but also spark debates in the public sphere about what these objects mean. Because when the detection rate increases, so does the chance of finding something profoundly strange. The more we see, the more likely we are to encounter the unexpected. And history shows that when humans encounter the unexpected, the reaction is rarely uniform. Some will demand aggressive investigation, others will urge caution, still others will see it through the lens of belief, interpreting it as proof of cosmic kinship or as a harbinger of something unknown and possibly dangerous. Right now, the newest interstellar visitor is nothing more than a moving speck in a stream of data, but within months, it will have a shape, a size, a color curve. We'll know how it spins, what its surface reflects, whether it sheds gas or remains inert. We'll watch it speed through the inner solar system and then fade back into the dark. And when it does, we'll either add it to the growing list of natural wonders or set it apart as something unique. Either way, the pattern is clear. These visitors are coming more frequently, or we are seeing them more often than ever before. The distinction may not matter. What matters is that we are entering an age when the boundary between our solar system and the rest of the galaxy is no longer theoretical. It's something we can observe, measure, and perhaps even cross. And one day, maybe sooner than we expect, something will cross that boundary, not in passing, but with purpose. It will not be here to merely glide past. It will linger, slow, approach. When that day comes, the years we've spent studying these interstellar passers-by will be more than scientific curiosity. They will be preparation. Preparation for the moment when the visitor is not just a traveler through space, but a traveler looking back. Until then, each detection is a rehearsal. This newest one is simply the latest reminder that the galaxy is not still, that our solar system is not a closed loop, and that the space between stars is not empty. It is a road, and traffic moves in both directions. The question that lingers is not whether we will see more of these objects. We will. The question is whether we are ready to act when the one that truly matters arrives. And if this latest detection is any indication, our window to prepare is opening wider with every pass of the Vera Rubin Observatory's gaze. We are no longer passive spectators in a static cosmos. We are residents of a crossroads, and the travelers are already on their way.